This is for the applet data for the ballistic pendulum and projectile motion. So this is, we're looking at here the original lab sheet, and these are the two applets that we're going to get to in just a moment. And this one here is the Excel sheet that I show you quickly. So here we go. And there's actually more than these two tables. There's one on the right, just there it is, just off the screen a little bit. This one here is the given bullet speed. This is the luxury that we don't have in the real experiment. That's actually what you have to figure out. You just don't know it. So of course the applet is able to give it to us. And then all this rest here, this is what we have to measure here for the ballistic pendulum there, and then for the two projectile motion methods we measure the height and the distance, and then we measure just the distance for a given 45-degree angle. Okay, so let's get started on this. So here's the ballistic pendulum applet, and we can see these input numbers that I chose. Notice that I'm trying to do 2 sig fig here to make it more realistic with the actual experiment, because there you're also not going to be able to measure much more accurately than that, and the outcome is also really not that accurate. You might have like 10-20% errors in here. For the applet, by the way, you will see that our errors are really small simply because the applet is virtually perfect. Okay, in any case, bullet mass here 14 grams, the mass of the pendulum 960 grams, the pendulum length 1.7 meters, and yes, the bullet speed is given here. Again, in the actual experiment we don't have that, 54 meters per second. And then all we really have to measure once it's actually going is the angle, and you will see that it's going to be a little bit tricky. So here we go, play, and notice that the angle, it just goes forth and back. It's going to go forth and back here indefinitely, so there's no air resistance. And so I have to measure this angle here, and that's going to be tricky for a couple of reasons. So here I just paused it and then go a step forward here. So 10.91, and that's actually it. So 10.9, and then I can't go back in my step here. It kind of like locked on me. So I'm going to try this one. I'm going to reset. And I noticed that before as I was prepping this one here. So obviously this is the same shot. And let's see if... I mean, I kind of know it already is 11 degrees because it's had two significant figures, and that's all we can hope for. So here I can't even go back anymore. So I'm going to round to 11 degrees. And what I mean is all we can hope for is that in the actual experiment, we cannot measure more accurately than 2 sig fig on the angle at all. All right. So let's go to the projectile motion. So here's the other applet, the projectile motion, and I prepped that as well. Here's our initial velocity of 54 meters per second. That's actually really fast, but notice on the ballistic pendulum, I really didn't have much choice. 50 is like the lowest one I could possibly have, so I went with 54 in this case. Much faster than the Nerf guns that we're using. Here's the acceleration due to gravity, 9.8. It doesn't give me any more digits anyway, so I cannot even apply the 9.82 for Alaska. Launch angle is 0 because I want to shoot it horizontal. And the height here is an incredible 12 meters. This is 6 stories up. I tried it for a smaller height for this one here with a more realistic height of 1 meter for our experiment, but watch what happens when I fire this one here. It's like, whoa, where's the cross? Actually, we could choose that. Hold on. There we go. Let's just do it. 25 meters for this perhaps more realistic height. But then it's also, oh, actually it's closer to, let's call it 24.3 meters. There we go. Okay, then I'm going to reset this one here. I'm going to leave the initial velocity at 54 meters per second, acceleration the same, but now we're going to have a launch angle of 45 degrees. So that's also realistic for the projectile motion that you need to do, and then shoot it from ground level. So, and then I have to zoom out. I'm going to get a really large range. Let's see. Might be even off the picture. Yes, it is. I'm going to zoom out. There we go. That's a little better. There we go. 200 and let's call it 297 meters. That would be 3 football fields. But again, there's no air resistance here, and it's a really large velocity, 54 meters per second. Okay, so those are the data. And let's go over to the Excel sheet. Oh, I already put the data in for the ballistic pendulum. So 54, that's the given bullet speed, the pendulum length 1.7, the angle 11 degrees. That was a little bit hard to measure. The bullet mass 14 grams, the pendulum mass 960 grams. Now for shooting horizontally from a given height, I only chose the 1 meter there, and then I measured a distance of 24.3 meters. And we see here 54 is what it calculates for the initial velocity, 54 is what it calculates for initial velocity for the ballistic pendulum, and 54 was the bullet speed that was given. So notice the results are actually perfect. By the way, the equations are right here. You can see it barely on the top. So they're, of course, in the Excel sheet. That's how I prepped it. Okay, the other one, the other projectile motion here, everything else is given, the 45 degrees. The only thing I have to put in here was the 297. And if I even round it to 300, we still get the 54 meters per second. Again, perfect results because these are perfect applets. Realistically, when you do the experiment, expect quite large errors, 10–20% or so. All right, the next one, so going back here to the ballistic pendulum. This time I'm choosing here 18 grams. Mass of the target, I'm going to choose 840. There we go. Bullet mass of 65. Wow, make it even faster. I really want to, this one I really want to have to 65. Ah, there, oh, so close. Oh, shoot. There we go, got it. And the pendulum length to 1.1 meters. So I'm changing all these parameters just to get different results here. Okay. Hit the target with the bullet, there we go. And then try to figure out what the angle is. So it looks like 22 degrees, 23, 24 degrees. That's it, 24 degrees. All right, going over to the projectile motion. So my speed was 65. It always shows me the result as I'm changing this one here. Really trying to get it onto 65. There we go. And I have to zoom out one more time, perhaps. Everything else stays the same, and reset and fire. There we go. And yeah, so I made it even faster. I'm really kind of restricted to the initial velocity that the ballistic pendulum actually allows me. So it looks like kind of like 430 meters here. If I zoom out, or if I zoom in, yeah, I'm actually off the screen here. So I'm gonna 430 meters as my result. Then I'm gonna go over to the horizontal shot. So here we go, but then I have to go to a certain target height. And here I'm really gonna zoom in. If I go to a realistic one of, well, sure, 1.5 meters, and fire, there we go. And it's such a shallow upside down parabola because it is so fast going across here, and it kind of looks like, let's call it 36 meters. And yeah, the height was 1.5 meters. Going over to the Excel sheet. So I didn't enter these numbers here, so the actual bullet speed is 65. That one, the pendulum length was 1.1. The angle that I measured was 23 degrees. The bullet mass 18 grams, and the pendulum mass 840 grams. And we can see that, yep, a little bit of error here, 840. I'm being 62 as compared to 65. Let me just go back here to this one here. Yeah, those are the same numbers. Okay. Interesting, that is a little bit off. Oh, 24 degrees, not 23 degrees. Let's see what happens. There it is. Yep. So perfect applet, hence result of perfect. Again, don't expect it for the actual experiment. Okay, this one here, I just did that. So the height was 1.5 meters and the distance was 36 meters. And again, I get the same result of 65 meters per second. And here for this one, I really only need total distance, 430. And again, I come up with the same result, 65 meters per second. All right, and third data set here, I'm going to leave the bullet mass at 18, change the bullet speed to, I'm going to try 76, there we go. And the mass of the target I'm going to do at 920. There we go, that's close enough. I'm going to round to 920. And then the pendulum length to 1.6 meters. There we go. Okay, hit the play button. And again, I have to figure out this angle measurement. So 20 degrees, 21. That's it, 21 degrees. All right, go over to this one here. So our new speed is 76 right there. Launch angle, it's horizontal, and then the height here, there we go. I can leave it at 1.5. Reset and fire, and it's again very fast. And this kind of looks like for a little bit more than 42. I'm going to round it to 42 meters. And again, my height is 1.5 meters. And then I'm going to go over to the 45-degree shot. There we go. And that one has to be from ground level, so 0. And I'm going to shoot. Set. Fire. There we go. Way off the screen, so I really have to zoom out. There we go. And there. This would be 6 football fields. So that looks like, to me, 590 meters rounded. Go to the Excel sheet. So that's 76. Pendulum length 1.6. Angle, then I measure 21 degrees. Bullet mass 18 grams. Pendulum mass 920 grams. And I come up with 75, so almost perfect, 1% off. The height here on this one here was 1.5. Oh, it didn't write that actually earlier. I would actually like to give it one more sig fig. Oh, I didn't. Oh, okay, yeah. I used really large numbers for my example here. So this is 1.5, 1.5 each time. And then this one here is 42. And again, I come up with 76. And then for the 45-degree shot, I measured 590 meters, and again, it comes up with the same number. So these are the data for the applet, and again, notice that they're really perfect results, and don't expect those kind of perfect results for when you do the actual experiment.